See. Okay, okay.
Yeah.
So is it helpful?
Yeah. Good evening, all. Yes.
Meaning?
Someone Mukesh, right? They're asking a query.
Yeah.
No answer.
Good evening, sir.
Yeah,
Good evening,
yeah,
sir.
yes. So yes.
Sir, I have one.
So before I start, right, first, can anyone please confirm whether my voice, whether the screen is visible or not, right? Yes. So yes, I'll come back to your query. So in the last class, just I was briefing you about introduction to big data Hadoop, right? So coming to your query, right? So if you go back like 10 years from now, like 2010, 12, right? So this Hadoop, big data Hadoop, it is only means only the Java people used to learn this Hadoop. Yes. If you go back 10 to 12 years, right? 2010 to when when Hadoop was introduced into the market, right? So only the Java people used to learn or update this Hadoop. No other people. If you know Java, then only you can update with Hadoop. That was the previous, right? But slowly, okay, in 2010, 12, at that time, during that time, right, there was a great hype for Hadoop. Even today also, but we have got PySpark and PySpark, we are still using Hadoop components. But mostly total implementation was done in Java. Hadoop, there is a component called MapReduce, right? We used to write huge Java codings, right? But what happened? Okay, people, because of that hype, everybody started migrating towards Hadoop environment. They started learning Java later into Hadoop, right? But slowly writing huge codings in Java, right? People started migrating from Hadoop environment to other. Frankly speaking, right? People started migrating again from Hadoop environment to other environments because of that. But slowly, what this Apache did, Apache Software Foundation, that is that where most of the Hadoop components are from Apache, it slowly decreased. Means because of these huge codings, slowly it has came up with the other components. Slowly it has come up with the other components like in Hadoop. So now this MapReduce component has totally got outdated. Now we are not using in the market MapReduce because where MapReduce totally require Java, where huge Java codings. Then later Apache came with a component called Apache Pig. It's Apache Pig. Apache Pig, right? Apache Pig, it has got a language called Pig Latin. It has got a language called Pig Latin language. Pig Latin language compare with Java, right? Pig, if 100 lines of Java code is equivalent to 7 lines of Pig. 7 lines of Pig Latin. Where is 100 lines of Java code? Where is the 7 lines of Pig Latin? 7 to 10 lines of Pig Latin. Okay. But again, because of this very less coding, right? And Pig Latin is a simple scripting language. Pig Latin is a simple scripting. It's a data flow language. Data flow means the output of one will be the input to the next one, right? Next flow. So it was very simple language. Again, it was very simple and easy to understand also, and to writing these pig scripts. We used to write many pig scripts, right? So slowly, people again, they like this pig Apache pig, and they have written many. But slowly, this Apache pig also got outdated. Apache pig also outdated because of Spark. Because of Spark. Spark is also a data flow language like Apache Pig. Spark is a very high speed processing as compared but what is the drawback with Apache Pig, you may ask? We have got very less coding, and also it is very simple, as I was saying, right? But why again still it got outdated means Apache Pig, okay, you are writing 7 lines. It is internally converted into this MR code. It is internally converted into MR code and get executes. Yes. this pig code, pig script is totally again converted into MR job, MapReduce job, and executes. Okay, here again, pig uses MapReduce execution. MapReduce execution is going to happen, right? But that is not the main drawback of pig. But when Spark came, Spark is also a data flow like pig. It is similar, right? Whenever you're using Spark, then no need of pig. So even today, Apache pig is, it's mostly used, right? When it was introduced, but slowly it also got outdated when Spark was introduced. Spark, today if you see the boom of Spark, right? Very high speed processing technology. So this Spark can be implemented in Scala language. When Spark, frankly speaking, when Spark was introduced into the market, it was implemented using Scala language. Scala is mostly used. Scala means scalable language, extensible language. It is a language taken from Java. Java is only object-oriented, but Scala is object-oriented, procedure-oriented, right? And it is script-based also. So Spark is, this only Spark uses the Scala language, but slowly after Scala, people started using Python. Instead of Scala, they started using Python. Python has got support to various functionalities and modules, right? So instead of using the Scala language, this Scala, okay, Spark totally built using Scala language, but Spark you can implement by using Scala language. You can implement our code with Scala. You can implement by using Python. You can implement by using Java, by using R language. Understand here? Multi-language support. Spark is a multi-language support. It supports through multiple languages. What all the functionalities of Spark are going to remain same, but only the coding is going to change. Just the coding is going to change, right? Very simple, right? If you see in Java, in Scala, in Python, only defining are the functionalities, collections, functions, types, these things are going to change, but the Spark functionality remains same in all this. Most this default Spark built by using Scala, but today mostly Python is used for implementing Spark, what we call as PySpark, right? Previously, Scala was used a lot, right? Now, very less companies they use Java because of huge codings, and also it's mostly Scala and Python is preferred. Java also can be used, like companies like Value Lab is using Spark with Java. Very less companies use, but remaining most of the companies are using Python, and some other companies, 60% of the companies using Python, nearly like 40% they are using Scala language, right? But you need to understand about entire Spark. It is an execution model, right? So if you see that a small difference, right? Only in the programming you will see the difference in defining or implementing, right? For example, if you want to define a variable, right? Where x equal to 10, sorry, you want to define a variable in Java, you say int x equal to 10. Same thing if you want to do in Scala, where x equal to 10, you say. In Python directly you say x equal to 10. Here you say compulsory we need to define the data type. Here we say where keyword. Here we won't specify anything. Only that these things. But if you talk about the Spark related, everything will be remain same in all this. So just now someone was asking a query, right? So programming is compulsory in this. Programming means either Python, Java. Means Java as where our course is PySpark, Spark with Python implementation, right? So Python has got all the features of Java, but as compared to Java, even I was saying, right? Python is also a kind of language which has got very less coding. 100 lines of Java code, we can write approximately like 20 lines in Python. Very less coding you see in Python also. Python skills we can write, right? So our course is PySpark, Spark with Python implementation. But don't forget, okay, what all the Hadoop components, everything. So Everything are built on top of Java. So for installing this Hadoop or Spark, everything, right? Java required, Java software compulsory. Without Java software, you cannot install any of this Hadoop or Spark, right? So first Java, later Python and Spark. These three softwares required for installing. Java is compulsory. Fine. Okay, Java process, but we are not going to write any Java code here. We are not going to discuss anything about Java, or we are not going to write any Java code here, not even a single line of Java code. So everything will be in Python, right? Everything is going to be in with Python. But okay, I'll come back about at the end of the session. I'll be briefing much about, right? So in the Hadoop, we won't use any language at all first. When going with Spark, we'll be using, but in Hadoop, we use like HQL, Hive query language, the other things. So yesterday I was just briefing you about what is big data, why Hadoop drawbacks with the databases, Hadoop and Spark advantages, Hadoop and Spark job market. Yes. So here mostly people who learn big data, this Hadoop and Spark, we got data engineers, we say, right? Okay, previously people who used to go for Informatica, Talent, that is ETL, right? Now everyone they are learning, they're updated with this big data, Hadoop and PySpark. So I was saying big data, huge volumes of data. We have got databases and specialized databases like Oracle, MySQL, DB2, and specialized databases like Teradata and Etija Vertica. These are used for data warehouse purpose, OLAP, analytical processing. Okay. Fine. So Hadoop, as I was talking, that Hadoop is providing two services. Any technology performs either storage or processing, but Hadoop performs both. Hadoop is meant for storage, storing the data, and storage. We are using Hadoop distributed file system for it. Okay. So if we talk about the C, C++, Java, they're meant for processing, and these databases for storage, but Hadoop performs both storage and processing. So meant for processing also. Yes, for processing, we are using MapReduce. Previously, it was used much, but now going with Spark. So you may ask, when we have got processing technologies available, storage technologies available, why Hadoop, again, Hadoop required, right? Hadoop, understand Hadoop is meant for hmm, batch applications. So there are two types of applications. If you talk, there are two types of applications, right? There are two types of applications. One is online applications. See, if you're making an online transaction, Hadoop is not required for one transaction, two transactions. For millions and trillions, right? Hadoop is required. So online applications, right? There are two types of applications, online applications. Second is like batch applications. First one, online applications means online applications. Yes. Online applications means user interactive applications. User interactive applications. Here user gives the input. Here user gives the input. Example, booking a movie ticket, right? Example, booking a movie ticket, right? making online transaction, making your online payment. Whenever you are making online payment, compulsory we need to provide, user has to provide the details, but user has to give the input. Second is like batch applications. Batch applications, right? Yes. User non-interactive applications. User non-interactive applications, right? User non-interactive applications. Here, user doesn't provide any input. User doesn't provide any input. Everything happens in the automated fashion, right? Example, for example, railway ticketing, right? PNR status. Your PNR status, your waiting status is 200. Later, after 2 hours, it becomes 150. Tomorrow morning, like 100. Tomorrow evening, it gets confirmed. Here, user has got nothing to do. Just it happens in that, right, background. Most of this, for example, generating mm, credit card statements, credit card statements, right? For millions of customers. Generating credit card statements for millions of customers. Yes. Okay. Most of these financial applications, banking applications are batch applications, right? Yes. So yes, drawback with the current databases, limited storage in most of the databases in GBs or in TBs, so no parallel processing. And if volume increases, right, speed decreases within the databases, decreases. So total amount from sales 1, total amount from sales 2, total amount from sales 1, total amount from sales 2, total amount from sales 3. Which query is going to execute faster, right? Among these three, which query is going to execute faster among these three? Query to query as this 10 records, 1 lakh records, 1 crore records. Means the first query executes faster as compared with the second and third, because volume 10 records here is 1 lakh, 1 crore. As volume increasing, speed decreasing. Even if complexity increases, speed decreases, right? Total amount from sales fund, average amount from sales fund, standard deviation from sales fund. So this is going to take more time as compared with this, right? Because first sum has to be calculated, next average has to be calculated. As compared from the first one, the second query taking more time. As compared to the second one, standard deviation, lot of internal processing is required. And the major drawback with databases can handle only structured data. Databases can handle only structured data, right? Yes. So before I go with advantages of Hadoop, right, you need to know something about this Hadoop. Okay, so before I discuss about this advantages of Hadoop. So Hadoop doesn't follow client server architecture. It won't follow client server architecture. Means generally when the client server means request response, it won't follow request response architecture. Whenever giving request, getting the response. Hadoop follows master slave architecture. Hadoop follows master slave architecture. Single master, multiple slaves architecture, right? So that we call it like Hadoop cluster. Group of CPUs, you can say, right? Nodes. CPUs means nodes. connected in a network. Group of CPUs or nodes connected in a network. Group of CPUs nodes connected in a network, right? So there are two types of nodes. One second. There are two types of nodes. Master node. Secondly, what? Master node and slave node. Master node in the Hadoop terminology, right? We got a name node. Slave node like a data node. Just observe this, right? Yes. Single master, multiple slaves. Single master and multiple slaves. S1, S2, S3, so on, Sn. So this is the master node. These are the slave nodes. These are the master nodes, slave nodes. Slave nodes, nothing but data nodes. Master nodes are data nodes. Here, data is stored by the slaves, data is processed by the slaves. Observe here, data stored by the slaves, data processed by the slaves. Master node or name node, we say, right? Name node. Once again, can anyone please confirm whether my voice is audible or not? Yes. Hello. Can anyone please confirm whether my voice is clear? Right. Fine, thank you. So single master, multiple slaves, master node or name node, and the slave nodes are data nodes. Data stored by the slaves, data processed by the slaves. For example, in Hadoop, always the data stored in the form of files, like files.txt files. Assume in database, right? In the form of tables, here in the form of file. f1.txt. Assume the file size is 2 TB. The file size is what? 2 TB. Each system 1 TB, 1 TB, 1 TB capacity. 1 TB, 1 TB, 1 TB capacity. This 2 TB file cannot fit into any of the system, any of the slave. So it will be divided into smaller parts. It is divided into smaller parts stored across multiple systems automatically, right? So any data file divided into smaller parts, we call it blocks. They are going to get distributed across multiple systems or slaves. Here, two advantages you can observe, right? Here you can observe two things. Two things. Distributed storage and parallel processing. What you are able to observe, distributed storage and parallel processing, where means your file is processed by multiple systems parallelly, right? Data is distributed across multiple slaves and data is processed by multiple systems parallelly, right? Yes. Okay, fine. Now see this master node or name node. It will assign task T1 task to system 2, T2 task to system, T3 task. Assigning task. Observe this. Master node responsibilities and slave node responsibilities, right? Yes. Master node responsibilities, right? Yes. First one. Task assignment. Task assignment, assigning tasks to the slaves. Load balancing. Balancing the load equally to all the systems, all the slaves, right? Fault tolerance. What do you mean by fault tolerance, right? So here, multiple systems are executing parallelly, right? Just observe here. Multiple tasks are executed by multiple systems parallelly. Suddenly, if any particular system is down, right? Then the task of it will be assigned to any of the other system. This process is called as fault tolerance mechanism, right? Yes. When multiple tasks executed by multiple slaves, then if any system goes down, then the task of it will be assigned to any of the other system. This process is called as fault tolerance mechanism. And also this master node is health monitoring of each and every slave, health monitoring. Okay. So, and slave node responsibilities, two responsibilities, like slave node responsibilities. First thing is, right, storing the data. Secondly, like processing the data. Storing the data and processing the data. Storing the data and processing data. Okay, so based on this, right, later I discuss in brief about this Hadoop architecture, right? But now Hadoop advantages, right, as compared with. So unlimited data storage, right? Unlimited data storage because of a feature. Horizontally unlimited scalability. Unlimited data storage is possible because of a feature horizontally unlimited scalability. So observe this. If you're running a business with very less number of slaves, for example, with 10 systems, right? With 10 systems. Yes, S1, S2, S3, so on, S10. So your business has increased, customers have increased, branches have increased, data is increased, means you cannot go with the same number of slaves. So your horizontally unlimited number of systems can be added. If customers increased by 100 times, data increased by 1,000 times. So your slaves means the systems horizontally unlimited number of slaves can be added. Very high speed processing because of parallel processing, right? Very high speed processing because of parallel processing. So very a small example, labor example, right, of this parallel processing. Difference between non-parallel and parallel, right? Non-parallel and parallel. Non-parallel and parallel. For example, one person preparing one item takes 1 minute. The same one person preparing 10 items takes 10 minutes. The same one person preparing 100 items taking 100 minutes, right? The same way, the parallel processing for one item, 1 minute, for 10 items, 1 minute, for 100 items also 1 minute. Yes. For one item, 1 minute, for 10 items. But in case of parallel processing, for one person preparing one item, 1 minute, 10 persons preparing 10 items, 1 minute, 100 persons preparing 100. There we are saying persons. Here we are saying systems, right? Yes. Can handle all varieties of data, structured, unstructured, and semi-structured. Can handle all varieties of data, right? Structured, unstructured, and semi-structured data. Open source, no licensing required. Yes. Open source, no licensing required. It's a commodity hardware, means very highly configured systems. It's not required. It can run on any hardware, right? Yes. And as I was saying, right, to check the speed of various databases, Yahoo has conducted a test to check the speed, right? It has taken a table of 100 TB. Task is sorting based on 16 columns. What is the time taken, right? Oracle has taken nearly 3.5 days to process this 100 TB data based on 16 columns. MySQL, right? It has taken 6 days. Teradata, right? Teradata is taken 4.5 hours. Netija has taken 3 hours. And finally, Hadoop has taken 3.4 minutes. Latest version of Hadoop has taken 1.2 minutes, right? So this is the speed of Hadoop. Hadoop speed is in minutes, but the other things in days and hours. But see the Spark, right? PySpark. It's 100 times faster than Hadoop. 100 times faster, right? Okay, that is. But we are using some Hadoop components, right? Hadoop components are required. Yes. Okay, later I come back about it, right? Next, uh, not only processing point of view, right? Processing point of view, right? Hadoop is proven in the market, not only processing point of view, even storage point of view also, that's been proven in the market. So for example, why I've got a query, why databases like Oracle won't support unlimited storage. Even for databases like Oracle, right? In the real time, we can go with multiple slaves. Why they won't support unlimited storage means, yes, observe. For example, databases and max limit on the number of slaves. Max limit on number of slaves. Okay, for example, first Oracle, right? It can go max with 256 CPUs. 256 nodes are CPUs. Secondly, MySQL can go max with 54. MySQL Express can go with max with 256 nodes. DB2, it also can go with the 256. 256. So all these databases going with max 256. But once the for example, for Oracle, we take a labor example like phone, your mobile phone, if you got 64 GB internal storage, if all the 64 GB internal, if you are just filling up, so the performance of the phone degrades, even sometimes it won't even start. The same way Oracle, if 256 CPUs are nodes provided, if everything is, if it is filled, right, even sometimes it won't even start, the performance will be degraded. Okay, fine. Even if you go for specialized databases like Teradata, right? It is going with 1024, right? Netija, it's going with 1024. Teradata like 1024 nodes. Netija like 1024 nodes. And finally, Vertica, right? 512. Even like specialized databases also, they cannot support unlimited storage because once they get filled, they cannot support data further. But observe here, right? But there is no limit. But there is no limit on the number of slaves that Hadoop can have. No limit on the number of slaves that Hadoop can have, right? Unlimited scalability, unlimited number of slaves can be added, right? So, so just observe this. Yahoo, when first time implemented Hadoop, Yahoo, when first time implemented, right? Hadoop went with 4,000 slaves, that nodes. Currently, Yahoo going with 12,000 slaves. Facebook, right? Facebook, when first time implemented Hadoop, when first time, yes, implemented Hadoop, right? It went with 8,000 CPUs or nodes, right? 8,000. Currently, Facebook, right? Going with 42,000 nodes, right? 42,000 nodes, right? So just like, not like 256 or 512 or 1024, unlimited number of slaves allowed, right? So Hadoop is proven storage point of view and processing point of view, right? So next, Hadoop ecosystem components, what I'm going to discuss as part of this course, right? Yes. Hadoop ecosystem components means which are mostly used in our real time, right? The components which are used, mostly used, Hadoop ecosystem components. First thing is, for storage, we are using HDFS, Hadoop distributed file system. This is for storage. We're not using any databases despite of the drawbacks of it. Next, MapReduce. You need to have some knowledge on this MapReduce, right? So I'll also brief you about this MapReduce. This is meant for processing. This is meant for processing, right? But I won't spend much time on this because it is outdated, but just I'll provide the knowledge because you need to have the knowledge about this MapReduce execution. It's meant for processing. It's a parallel execution model meant for parallel processing, and Apache Hive, right? It's one of the important component of Hadoop, right? Mostly used in every product, that's in every project. Since you have mentioned the MapReduce outdated, does it still work? Is it? Yes, yes. The total our Spark is going to total our course mainly like 70% of our course will be Spark only, right? 60 to 70% of the course, everything deals with Spark, PySpark. Okay, Apache Hive, right? This is also meant for processing only. It is also meant for processing. Yes. Here we use a language called HQL, Hive Query Language, similar to SQL, right? It is meant for processing. We are going to make the data structure, creating Hive tables and performing querying on this, right? Yes. Right. And apart from this Apache Hive, right? Okay. We have got one more important component like Scoop. Scoop means SQL plus Hadoop. The first two characters of this SQL and the last three characters forms scoop. Scoop is for import or export operation, importing from databases to Hadoop and also exporting from Hadoop to databases for importing or exporting. During this import or export operations, right, we can perform many operations like filtering, grouping, segregations, selecting only particular columns, rows, right? Apart from this, we'll also we also discussed like NoSQL, a NoSQL database, NoSQL database, right? So for random access, schemaless behavior, right? Mainly schemaless behavior means in SQL database, right? From first record. One second. Yes, Mukesh, I'll come back to your queries point. Okay. NoSQL schemaless behavior, random access. Schemaless means in SQL, right? From first record to last record, same number of fields has to be maintained. But in NoSQL, first record with 3 fields, second record with 5 fields, third record with 7 fields, fifth record with 10 fields. Record to record, different number of fields of columns can be maintained. So as part of the course, I'll be discussing HBase for NoSQL database. So for online processing, yes. Apart from this, right, you will be discussing on Yarn, yet another resource negotiator. So from Hadoop 2 version onwards, we got some architectural changes, how this Yarn processing, Yarn components, and also like Zookeeper, controls and coordinates, all the other Hadoop components. Okay. And apart also like streaming technologies like Flume Kafka, Flume or Kafka, Flume Kafka, right? For streaming data which keeps on generating, data which keeps on incrementing. For example, if you take a movie, 2 GB movie file, morning or afternoon or evening, you'll see the same. The size will be same. It won't increase. It will be 2 GB only. But if we take CCTV or webcam, right? Today morning file size was 2 GB, afternoon it will become 4 GB, evening becomes 8 GB. So it keeps on incrementing, keeps on generating such type data. We call it like streaming data. For capturing such kind of data, right? We have got Flume, Kafka, and finally, right? Spark, PySpark. So major, our discussion will be more on this PySpark in this like Spark core. Spark core programming, Spark SQL programming, like Spark core, Spark SQL, Spark streaming. And also a part of Spark ML machine learning, right? Spark ML, this is what I will be discussing, right? Mainly. So nearly 70%, 60 to 70%, right? For course duration will be spent for this PySpark only, which has got a great boom today. And remaining 30% of our time will be spending for this Hadoop, which are more used. In that Apache Hive for this, it will be using more, right? So this is this course content. 1 second. So introduction, right? What is big data? Need for Hadoop for storage and processing. HDFS for distributed file system, right? And for map reduce. So just the picture of it and how this mapper reducer faces. Scoop, mostly used how to perform import and export, right? From databases to HDFS to Hive to HBase, performing various transformations, filterings, groupings, mergings, all these things before in during import operation. Yarn, yarn processing, yarn components, NoSQL database types of NoSQL, HBase I'll be discussing, right? And Hive is the most important component of Hadoop. Be discussing more time for this. Hive built-in functions, loading data from local files to Hive, loading data from HDFS to Hive tables, internal tables, external tables, working with unstructured, working with XML data, JSON data, URL weblog data, right? File inserts, UDF, user-defined functions, user-defined aggregated functions, user-defined tabular functions, partitioned tables, multi-column partitioning, dynamic partitioning, performance tuning mechanism, right? Okay, yes, performance bucketing, indexing, static partitioning, dynamic partitioning, multi-column partitioning, combination of this bucketing indexing. And if we come to this PySpark, we have got, I think, huge built-in, we've got many built-in functionalities, right? We don't need to write huge codings. So PySpark session, PySpark context, PySpark repartition, PySpark broadcast variables, accumulators. So DAG transformation. So persistence options, memory and disk, PySpark core computations, fault tolerance mechanism, aggregations, groupings and aggregation, various actions and transformation, one by one transfer, inbuilt transformations, many SQL, PySpark SQL data frames, creating data frames, struct, type, row, select, collect with column, where, filter, drop, order by, group by, union, right? PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions. PySpark built-in functions when EXPR, lit, split, substring, translate, overlay, to date format, months between, explode, array contains, array, select list, create map values, struct. So in this way, all the built-in functions one by one with many working examples, right? PySpark external sources, Spark and Hive integration, Spark and MySQL integration, working with CSV, JSON, narrow transformations, wide transformations. Adding of new rows, dropping columns, handling nulls, right? Yes. Writing back to external sources, deployment mode, local mode, cluster mode, PySpark application, stages and task drivers and executor, building Spark applications, PySpark streaming, integration with Kafka and MLA. And also you'll be provided knowledge on this Python. If anyone doesn't have knowledge, let Python basics, Python operations, editors, IDEs, data types, variables, constants, comments, input output type conversions, escape sequences, strings, operators, different types of operators, IDEs, working with different Python IDEs like PyCharm, PyDev, Spider, Eclipse, NetBeans, right? Flow control statements, looping statements, strings, string indexing, string slicing, string function, string method, string special characters, collections in Python, right? List tuple sets and list operations, list indexing, slicing, their functions, methods, right? Python tuples, Python sets, set methods, set operations, Python dictionary operations, functions in Python, properties, non-default, default, keyword, non-keyword, variable length arguments, right? Yes. modules in Python, different ways of importing, renaming, reloading, packages, errors and exception handling, right? Okay, file handling in Python, object-oriented programming concepts in brief, regular expressions, database connectivity, working with the database, Python datetime module, OS module, advanced concept like iterators, generators, closures, working with CSV, XML, GUI programming, Excel workbook, data analytics, reaction to data science, Pandas model in brief, NumPy model in brief, and Matplotlib model in brief, right? Yes. Okay, these 30 topics of Python, right? So as I said, Hadoop, PySpark, Linux. People who wants to go with this, right? Yes. 12,000 is the fee for this. And with the Python, if you want, right? If you want to buy with Python, right? 15,000 is the fee structure. Want only Hadoop and PySpark and Linux, it's 12, but with Python, right, it is 15. So Python, like nearly like 2 months classes will be there for this Python. You can attend any of my weekday, like Monday to Friday, you will be having classes for this Python. When Python is going, you'll be parallel this Hadoop, PySpark and Linux, it's a weekend. Only on Saturdays and Sundays will be there, right? So initially it will be taken, it will be starting at 7 o'clock. All right. After 3-4 weeks, right? So it will start at 6 o'clock. Initially it starts at 6 p.m., right? 6 p.m., right? 7, sorry, it starts at 7 p.m., but later after 3-4 weeks, it will be at 6 p.m., right? 6 to 8. But as of now, it will be starting from 7 to 8:30 or 9. So 2 hours on Saturday, 2 hours on Sunday. Fine. Python 2 months, Monday to Friday, you will be attending. So parallelly, Hadoop and Python you will be learning. Once nearly 60 to 70% of the Python when Hadoop completes 60 to 70% of Python completes, right? We'll be starting with PySpark. By the time you'll be having the knowledge of this Python core programming. So for this Python, right, people, if you want to attend, there are multiple batches I'll be handling for Python also. So tomorrow at morning 6 a.m., right, there is a Python batch. Morning 6 a.m. tomorrow, there is a Python batch starting, right? Okay, you can check with that. You can check in the DURGASOFT online. Right, you can see the contact details, right? You can just now itself you can contact them, right? For any, you can see in the chart panel there the big message is given, right? The course content, and if anyone didn't attend yesterday video, the yesterday video link, right? And that contact details of the online team. Okay. And if you are performing any payment, right, don't forget to share the screenshot of your payment to the online team, to the mail ID provided. Then only they'll be forwarding the link, right? So tomorrow at 7 a.m., that is 27th May, that is tomorrow, you'll be having. Again on this, on 30th May, there is one more, right? 8 p.m. in the evening, right? There is 30th May, there is for Python, right? If anybody, if morning you want, it's tomorrow at 6 a.m. Evening you want, 8 p.m. on 30th May, that is on Thursday, coming Thursday. This is on Monday. It is for Python, right? So we'll be getting the entire knowledge of Python for advanced programming. Linux will be discussed, means how much knowledge required for that HDFS commands, Hadoop commands, that will be discussed. PySpark in brief, in depth, you can see the syllabus course. And you'll be getting the live videos, live session videos. Every session video of Python you will be getting, of this Hadoop, PySpark and Linux, all these videos you will be getting, right? Classroom soft copy of notes, assignments and tasks to work, and a WhatsApp group for technical discussion, right? So this is what the offerings, right? So you'll be getting the videos, notes, assignments, tasks, and a WhatsApp group for the technical discussion. For Python, you'll be having one group, and for this big data, you'll be having, right? Yes. So yes, there were some queries asked, changing from. Viraj, you are from which time zone?
I'm from Pacific. So right now it is only 30 minutes, but I think
Which country you are from?
California.
Okay.
But
So-
right now I'm in Hyderabad though, just FYI this week, but that might little bit. Is there any reason for moving to 6?
So 9 p.m. it's too right? It's Saturdays and Sundays, weekends, right?
Yeah, it's weekend. So 6 p.m. here is like our 5:30 a.m. in the morning.
6 p.m. is 5:30 a.m. in the morning. Okay. So this is okay.
No,
So
if
most
there is
of
a valid reason, then I can adjust, but I'm just checking.
so most of the students, right? Yes, most of the students, right? They wants to be early, little early, right? There are some lady students also will be there. They want to complete before 8:30 or 8.
Okay.
Okay, for the first of the next 3 weeks, it will be right at 7 p.m. only, but later it will be at 6 p.m.
Okay. Yeah, I think for now it's only 30 minutes, but once we have, I don't think the course will go for time zone change. Then it will become 1.5 hours actually for us. But I don't think the course will be continued till that point.
Okay, fine.
Anyway, right now 30 minutes. Yeah.
Okay, fine, right? That's fine. So that's what I'm pre-intimating before you go with the payments, right? About the timings. So that's why most of these big data batches will be in this evenings, right? So seeing all the time zones, right, of US time zone, all this. Okay, fine. So next week, next Saturday, we'll start it. We'll be having class at 7 p.m. We'll be going with the technical part of this, how exactly the data storage and processing is going to happen in this Hadoop environment. But next Saturday, you're supposed to get enrolled, right? Your link is going to change. You will be getting a new link to your email, right? To your email you will be getting. Still, you can just copy the the contact details of this online team. Okay, you can see that contact details are provided. 3 contact details are provided. Payment details are provided. Yes, Google Pay numbers, Phone Pay numbers are given. And the course content is provided. ST video is provided. Big message is given, right? Yes. Rest you will be getting, even if you are missing any session, right? You will be getting the recorded of that entire session, right? Every week. For example, yesterday's video, today's video, all the videos, every session video that day within by tomorrow morning, you will be getting the video of today's. Yesterday's videos today morning, you'll be getting in this way. Every video, every session video of Python or this PySpark or Hadoop, all these videos, right? Yes, we will be getting the videos, but you can only view them. You cannot download them, right? Yes. So in brief, in depth of this PySpark will be discussed, right? With many working examples. Fine. And all the sessions will be interactive sessions. At any point of time, you can ask query. And even when I am performing this processing, all the operations, right? You people will be responding, right? Either you can unmute yourself and ask the queries through voice, or you can type your queries in the chat. All the sessions will be interactive. Only thing is regular to the sessions. Even if you miss any session, immediately go to the video and just ask the queries about it in the next session. Or no need to wait until the next session, right? Even you can just take the snap of that. If you get any error, you take the snap of it and keep in the WhatsApp group. Anybody can answer it. I'll be answering it, right? Yes. So no need to worry about the software. I'll be providing the software. I'll be forwarding it to your Google Drive, and also I'll demonstrate how to work on it. Yes. And also on the how to work on these IDs. Is there any Python class watch in the morning by 8 a.m.?
Hello.
Evenings not possible, right? Sandeep Patel, 8 p.m. in the evening.
Yeah, 8 p.m. is again afternoon, so it is a bit difficult during the office hours.
Recently, a 8 a.m. batch was started. If you can go to the just like 3 to 4 days back. If you can go through the videos, right? And if you can
Okay.
join that 8 a.m., right?
Okay. The Python only, right? Yeah.
Python on.
Okay. Okay.
You
I'll
can
check
just,
that, sir. I'll just call you and I'll check this. Yeah.
yes, there is an 8 a.m. I can check with them. Fine. Yeah, any
Hello.
other? Yes, yes, go ahead.
Hello, sir. Mukesh this side. Good evening.
Yes, go ahead.
Uh, I'm working as a Java full stack developer in one of the MNC. Okay, and
Mhm.
my manager told me we need to learn the Spark. So really, is it helpful for me?
So Apache Spark
So,
is one of the booming it's a very booming technology in the market, right? You can see that you
Mhm.
can you can just Google and check, right? The boom for it. And also, even if you go through that salary package also for that PySpark, right? It will be 1.5 times more than other any technology, right? You can check it, right? In the same way, they'll be expecting that command on that technology, right? Yes.
Okay. But here, how you will integrate with this Java application? Can you, miss? I don't know about anything, right? Miss, how to?
See here, one thing is I already said this Hadoop or PySpark is not for request response architecture. It's not for
Okay.
it's not for web application. It's not for client server architecture. It's more master slave architecture, right?
Okay.
We are not going to, if we are giving any request response for that kind of architecture, we are not going to follow it. Huge data, you are just going to pull the different data from different data sources, bringing to one location, right? That is Hadoop. From there, we are going to process it as per the business logic. From there, again, you can export the data to the other sources, right? And thereafter, if you want, you can apply like ML techniques, ML data analysis predictions and visualizations,
Mhm.
right? From the processed data, right?
But
So today,
in Java, Mhm.
yes, yes, go ahead.
Miss in Python, you will explain there, na? Okay, how to retrieve the data, how to store the data, how to pass the data.
Yes,
But
yes,
in Java
everything.
side, so but from Java side, so
Hmm.
then how you will explain?
We are not going to
Some Java.
discuss, we are not going to discuss anything about a single line of Java code.
Okay, so then will I cover this topic with how to connect with uh, big data and Spark?
Means you're talking about how Java can be used,
Uh-huh.
how Java can be used, and how Java can be implemented within this Hadoop. And
Yes.
if you want, you can
Spark.
just you can, if you've got knowledge on this Spark, you can, if you've got knowledge on Java, you can just implement Spark using the Java also. You can say, right,
Okay.
you know Spark, and I can implement using Java language. Means when you are implementing using Python, it's not a big deal. Implementing using Java. Already if you have got the Java coding, right?
Yes, I
But
know everything in Java, but
whether you are implementing in which language. See, if we talk about, for example, a small mini project, college management system, right? You can implement
uh,
in Python, you can implement in Java, you can implement in any language, right? In the same way, Spark is an execution model. You'll be learning about all of that functionalities of it. That implementation, how you code, you can go with different languages, right?
okay. But project, will you take the project on this?
So I'll be discussing
Project
one flow at the one. I'll be discussing one flow at the end.
Okay, but
What?
through the Python language or what? Which language you will?
Python only. See, I'm saying I'm not going to use any one line of Java code here.
Okay.
So totally it is Spark with Python implementation, right? Okay. Hadoop, Spark with Python implementation, and this Python, 2 months of Python course you will be getting apart from this, right? Right?
Okay. But
So yes.
but
So
if I
here,
learn,
yeah, go ahead.
Mhm. But if I learn Hadoop and Python, so it is helpful for me right now. Means I can also easily connect with this both, right?
Yes. Python, here you can go with object-oriented programming, Python with procedural-oriented, Python with scripting, and also with the modeler, right? But in Java
Yes.
only this object-oriented programming, right? So
Correct.
even, okay, fine. Okay, so here for Hadoop PySpark and Linux, it is weekend, right? We will be going with nearly like it takes nearly 12 weekends. 12 weekends means it goes for 3 months. Means in a month of 4 weekends, right? Four means it goes to 12 weekends, right? Because we are learning actually previously Hadoop was a separate course, PySpark is a separate course, but we are providing Hadoop PySpark and 3 courses you are learning. But this Python course in the weekdays from Monday to Friday, but Hadoop and PySpark. So right, out of
Understood.
12 weekends, nearly like 4 to 5 weeks on Hadoop, remaining everything will be for PySpark, right? Yes. And
Okay.
before we go with the practical, you'll be given knowledge on this Linux. Everything goes in Linux environment, right? Okay, fine. Any
Okay.
other queries with
SpicePark,
anyone?
SpicePark, SpicePark, nothing but Apache Spike, no?
Apache Spark with Python implementation. So Python is giving you a package, right? Like PySpark, where you can deal with all this functionalities.
Okay, Miss
Spark,
Apache Spark is different and PySpark is different, right?
whenever
Or no?
you say Spark is a execution model, implementation goes in, you can use Scala language, you can use Python language, you can use Java
Okay.
language, mostly used. Means implementation coding of the Spark, right? Spark with Python, generally we say like PySpark. Whenever you
Okay.
say only Spark means default, it is dealt with Scala language. Okay. But these days, Python is mostly used for implementing, right? Okay, fine. So
Okay.
you can just check with this, right? There's a so the online team, there is a separate online team for forwarding the videos, right? Yes. I'll be forwarding the notes, clear notes, right? How long will the course run? Hadoop and PySpark, right? So I said it will be for in brief, we'll be discussing that for 12 weekends, right? 12 weekends it goes. And Python will be in the weekdays, right? Yes. And any other queries for anyone, right? Everything you'll be understanding clearly, point to point, right? Only thing is be regular to
Yes,
the
sir.
class.
Thank you.
If you miss any class, right, you can go to the video and try to interact in the sessions, try to ask queries during the sessions. I want the sessions to be more interactive, right? Right. Fine. Okay. So I'm stopping for now. We'll continue next Saturday at 7 p.m. But the link will be changing, right? So you are supposed to get enrolled. So there is a package available, right? Yes. For this is for Hadoop, Big Data, PySpark, and Python 2 months course. But so here there is two package. One package is like in Big Data, you'll be learning Hadoop plus PySpark plus Linux and Python core and advanced, right? Python core and advanced. You'll be learning this core programming and advanced programming. This is 15,000, right? Where you can go with. But some people, even if you have got good knowledge on Python, if you're looking for Python jobs, plus if you want the frameworks of Python, right? Frameworks of Python, even I'll be discussing frameworks like Django framework of Python, Flask framework, and this REST API, right? For this frameworks, right? So for entire this, there is a package like 20,000, right? Even if you want the Python frameworks, even if you want to, if you have got knowledge on these things, even you can, your job search will be little broad. You can go as a Python developer, Python full stack developer, you can go with this Python core advanced frameworks like Django, Flask, and REST API. And even you can go as this Hadoop Spark developer, right? PySpark developer. Yes, this is that if you want to have this, fee structure is 20,000, but for Hadoop, PySpark, Linux, and Python, it is 15,000, right? For this also, batches will be available once if you have got knowledge and you can attend once you enroll, right? Once you get enrolled, you can attend any of my Python, Hadoop, PySpark, or Django batches whenever they are getting started, right? Yes. Yes, Ubuntu Linux, whatever, what flavor of Linux means Ubuntu, mostly Ubuntu will be using. Even CentOS also fine. CentOS also is fine, but Ubuntu will be much better, right? Yes. Okay, fine. So don't worry, people who doesn't have knowledge on Linux, everything, the commands I'll be briefing before I go with the practical part, right? So, fine. So I'm stopping for now. We'll continue next Saturday at 7 p.m., right? So get enrolled for getting the link to your, yes. Thank you all for your time. Thank you. Meet you next Saturday. Good night.
Thank you.